A junior sysadmin just spent 72 hours manually RDPing into 50 new Azure VMs. One missed patch almost cost the company millions in incident response. The only way out is to never log in at all. And today, you'll learn exactly how. By the end of this video, you'll own 3 real skills. First, you'll fire any PowerShell script into an Azure VM without touching RDP. Second, you'll know exactly when to reach for desired state configuration, a declarative engine that enforces a desired state on a VM, or the Chef extension, which connects a VM to a Chef server for cookbook-driven management, or a custom-built extension. And third, you'll join a VM to a domain, deploy agents, and bootstrap apps, all through automation, all repeatable. Last time in Part 8, we settled the IaC showdown: ARM, Bicep, or Terraform. You now have a perfect template to stamp out VMs on demand. But here's the catch. Even the slickest infrastructure as code pipeline leaves you with a freshly baked VM that's missing half its configuration. It's not production ready until the software is installed, the security agents are humming, and the domain join is done. That's where this episode picks up. Automating post-deployment configuration so you never waste a weekend manually RDPing again. Here's what the manual trap looks like. You spin up a VM, open RDP, install software, tweak registry keys, reboot, verify, then repeat for every single server. Each manual cycle can easily consume half an hour or more, and humans are terrible at repetition. We miss steps. We type version numbers wrong, and one subtle drift between 2 VMs can break your entire application. The solution isn't more careful clicking. It's removing the human from the loop entirely. Let's lock in what we just learned. Before we move on, let's introduce the silent worker inside every Azure VM, the Azure VM agent. This Windows service, running as WAAP-agent.x, is pre-installed on all marketplace images and listens for commands from the Azure control plane to run extensions like custom script. Now, a quick recall. What tiny Windows service, pre-installed on every Azure Marketplace VM, listens for extension commands from the control plane? Imagine Azure as a project manager and the VM agent as the technician inside your virtual machine. When you deploy an extension, Azure doesn't log into the VM like an administrator would. Instead, Azure sends a secure instruction to the Azure VM agent that's already running inside the operating system. The agent downloads the extension package, verifies it, installs it, and reports the results back to Azure. Every extension, whether it's custom script, Azure Monitor Agent, Defender, or another Microsoft extension, uses this same communication path. Understanding this architecture explains why nearly every automated VM management task in Azure begins with a healthy VM agent. Here's the exact pipeline. Your PowerShell script sits in Azure Blob Storage or a public GitHub repo. When you trigger the custom script extension, you pass it the file's URI in the file URIs setting and the command to run in command to execute. The extension downloads the script, the VM agent hands it off, and it executes under the local system account. Full admin rights, no prompts. You can attach it at deployment time or fire it against an existing VM later. That's your automation Swiss Army knife. A development team needed 30 test VMs fast, Chrome, 7-zip, a specific .NET runtime. They RDP'd into every single one and ran Chocolatey commands by hand. By VM 12, someone fat-fingered a version number. By 19, a different version crept in. The automation scripts that relied on those tools started failing with mysterious errors, and the team burned 3 days hunting down version drift. The fix? A single custom script extension with a Chocolatey script that pinned the exact versions, deployed once, identical across all 30 VMs. No drift, no heroics. And that's the power we're about to unlock. Here's the anatomy of the custom script extension. It all starts with a simple JSON payload that the VM agent receives. That payload has two main sections. The public file URIs array, a list of URLs pointing to your PowerShell scripts, typically stored in Azure Blob Storage or GitHub. Then the command to execute string, the exact PowerShell invocation to run. But any secrets, like storage account keys or credentials, go into protected settings, not settings, because protected settings are encrypted and designed to keep secrets out of logs. Misplace a secret in the public section, and you risk exposing it in logs without blocking the download. Always use protected settings to keep it safe. Here's a real first script you can drop into a custom script extension. It sets the time zone, installs Chocolatey if it's not already there, then silently adds Chrome and 7-zip. The key detail? That -y flag after each Choco install command. Without it, Chocolatey would prompt for confirmation. And because the extension runs headless with no user input, the script would hang and eventually time out. Always make your script non-interactive. Quick recall. What's the one flag that separates a successful deployment from a 3 a.m. timeout? Quick checkpoint. Your script hangs every time. Which two silent killers are most likely responsible? Adding the custom script extension through the portal takes less than a minute. On your VM, go to Extensions plus Applications under Settings, hit Add, and search for Custom Script Extension. Pick the one published by Microsoft.Compute. Browse to your storage account, select the script, and finish the wizard. The agent will download and run it immediately. No RDP required. When the script fails, the first place to look is under the folder C:\Windows Azure /logs/plugins. That's where the extension agent writes its own execution log. Next, check the packages /plugins. Download folder to verify the script file actually arrived. And if you added your own logging with start transcript or write output to a known file, that's your third and often most useful source. Pro tip: always redirect script output to a dedicated path like C:\Azure deployment /install.log, so you never have to dig through system directories at 3 a.m. Recall: custom script extension is excellent for one-time configuration tasks, but desired state configuration takes a completely different approach. Instead of simply running a script and stopping, DSC continuously verifies that a server remains in the state you've defined. Imagine declaring that IIS must always be installed and the World Wide Web publishing service must always be running. If someone accidentally removes IIS or stops the service, the local configuration manager detects the drift and restores the desired configuration automatically. This makes DSC especially valuable for enforcing consistency across large server fleets. While the technology is approaching retirement, understanding its declarative model helps explain the evolution of modern configuration management. As Azure environments evolved beyond traditional virtual machines, Microsoft introduced Azure Machine Configuration as the successor to the DSC extension. Instead of managing configurations separately on each VM, Machine Configuration integrates directly with Azure Policy, allowing administrators to evaluate and enforce configuration across Azure VMs, Azure Arc-enabled servers, and hybrid environments from a single control plane. Rather than simply asking whether a server is online Organizations can now verify whether it remains compliant with security baselines, software requirements, and operational standards. If you're starting a new deployment today, this is the technology you'll increasingly encounter in enterprise environments. Not every organization manages infrastructure the same way. Some enterprises have invested heavily in configuration management platforms such as Chef, Puppet, or Ansible long before moving workloads into Azure. For those organizations, the Chef extension provides a bridge between Azure virtual machines and an existing Chef infrastructure. During provisioning, the extension automatically registers the VM with the Chef server and immediately applies its assigned run list. If your organization already depends on Chef, this creates a seamless onboarding experience. If not, Azure native tools like Custom Script Extension and Azure Machine Configuration are typically simpler choices that require far less operational overhead. Sometimes Custom Script, DSC, or Chef just don't fit the exact tool your shop needs. Maybe you have a proprietary monitoring agent that only installs with a Windows MSI and a registration token, or a legacy app that needs a dozen registry tweaks before it starts. When no built-in extension covers it, you can build your own custom extension. You package your executable and a manifest file into a zip, upload it to a storage account, and register it under your own publisher namespace. Azure Resource Manager treats it exactly like any other extension. Deploy it through the portal, CLI, or inside an ARM template with the same syntax. Let's talk about time. Manually logging into a new VM, clicking through installers, and tweaking settings eats up a big chunk of an admin's day, and that's per VM. When you fire a custom script extension, on the other hand, the configuration kicks off almost instantly and then runs in the background, freeing you up for other work. DSC's declarative model enforces your desired state continuously with no extra clicks. And if you're already using Chef with prepared cookbooks, applying the run list is just as hands-off. The productivity gap is huge once you start deploying at scale. Recall, checkpoint, DSC versus CSE versus Chef. One of the most valuable automations in Azure is joining newly deployed servers to Active Directory without ever exposing credentials. Instead of storing passwords inside scripts, templates, or pipeline variables, the virtual machine authenticates to Azure Key Vault using its own managed identity. Azure verifies the VM's identity, retrieves the domain join secret securely, and passes it directly into the PowerShell script. No administrator ever sees the password, and no secret is committed to source control. Once the credential is retrieved, the script joins the machine to the domain, places it into the correct organizational unit, and reboots automatically. This approach combines automation with zero-trust principles by eliminating hard-coded credentials entirely. A single command to execute inside your custom script extension can silently install every agent a new VM needs. First, the Azure Monitor Agent MSI runs with the silent switch so it never asks for input. Right after, the Defender for Endpoint onboarding script executes with your provisioning package, and then your own internal agent follows. All three install in sequence while you're off working on the next task. No clicking, no waiting, no mistakes. Here's the exact portal flow to deploy a domain join script using the custom script extension. You start at the virtual machine's extensions blade, add a new extension, and pick Custom Script. After selecting your PowerShell script from a storage account, you define the command line and, critically, store the domain join password as a protected setting instead of typing it directly into the public command string. Once you hit Create, the extension runs, the VM reboots, and it comes back as a member of your domain. No RDP needed. Once Chocolatey is on the system, installing apps is almost too easy. You add your internal package feed as a source, then install everything with one Choco install command. The -e flag answers yes to every prompt, so the script never hangs. In this example, Google Chrome, 7-Zip, and your own company's agent all land on the VM without human intervention. And because we defined an internal source, you're not dependent on the public community feed for your proprietary tools. Infrastructure. As code doesn't stop when the virtual machine finishes deploying. In a modern Azure environment, the VM resource and its extensions are defined together inside the same ARM template, Bicep file, or Terraform configuration. As soon as Azure provisions the operating system, the extension installs monitoring agents, joins the machine to the domain, deploys business applications, and performs any additional configuration required before the server enters production. The important rule is that every script must be idempotent. Running the deployment once or 10 times should always produce the same final configuration without creating duplicate software, installations, or unexpected side effects. That's the foundation of reliable cloud automation. Recall, checkpoint, idempotency, and safe scripting. Recall, checkpoint, IaC and idempotency. Even the best automation occasionally fails, so knowing where to investigate is an essential cloud engineering skill. Start by checking the extensions blade in the Azure portal to determine whether Azure reports the deployment as successful or failed. Next, examine the extension logs under the Windows Azure log directory to see exactly what happened inside the VM. Verify that the script downloaded correctly before assuming the script itself is broken. Finally, test the script manually on a clean virtual machine outside the extension framework. Separating infrastructure problems from script logic dramatically reduces troubleshooting time and helps you isolate the true source of failure. The number one killer is file paths. Inside the JSON, every backslash must be escaped with another backslash. So, C:\\Windows becomes C:\\Windows. Miss one and the whole command string breaks. Second, in the protected settings block, always wrap the command with escaped double quotes, not single quotes. The agent's JSON parser treats single quotes as a literal character, not a string delimiter. Also, be aware that the extension only captures the last 4,096 bytes of script output. If your script produces more than that, earlier log lines are lost. So always redirect detailed logging to a custom file instead of relying on stdout. Finally, don't use PowerShell single quotes for anything the extension needs to parse as a string. Stick to double quotes, escaped properly, and test with a tiny Hello World script before going big. Quick recall check. If you remember the answer, you're already ahead of most admins who discover this limit at 3 a.m. 3 concrete skills you now own. 1. You can push a script into a VM at scale, no manual RDP ever. 2. You understand DSC's role and the timeline to migrate. 3. You can join a domain, install monitoring agents, and load line-of-business apps without a single interactive login. That's the difference between a junior admin burning weekends and a cloud engineer who owns the process. Today you've learned how professional cloud engineers eliminate manual RDP sessions by automating every stage of virtual machine configuration. But automation doesn't end once the software is installed. The next challenge is keeping those virtual machines healthy throughout their entire life cycle. In the next lesson, we'll explore Azure Monitor, boot diagnostics, log analytics, and proactive troubleshooting techniques that help detect problems before users notice them. Together, infrastructure as code, VM extensions, and monitoring form the foundation of modern cloud operations. Master these three areas, and you'll be managing Azure environments the same way enterprise engineering teams do every day. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.